So today we're going to be working with our exponent rules. We have 3 examples below, one for each of the type of exponent rules that we're going to be doing. And then if you look through your packet, you will have a page to practice each one of the different exponent rules. Our objective is to simplify expressions that have exponents, and our CFS is listed at the top here. So we're identifying our like bases or things with the same variable. We're identifying then rules we can use, and then our end goal is to simplify. So let's look at our first example here. This rule is talking about if I have 2 variables or 2 things with exponents that I'm multiplying, my shortcut is that I can add the exponents. So let's take a look at my first one here. We have a to the third, parentheses a to the sixth, b to the fourth. Now if I have something next to parentheses, that's another way to just say I'm multiplying. So that's an example of this first rule here. I see that, well, if I'm looking to identify like bases, I see a to the third and a to the sixth. We're multiplying them, so we're going to use our rule off to the side and add the exponents. So a to the 3 plus 6 power means we're going to have a to the 9th power. Now I look and I don't have anything to go with our b variable here. So we're just going to bring that down. That can't be simplified. It can't be combined with anything. So we have b to the 4th power. Our second rule, first of all, make sure that you have this example written down, but also having the rule written down. That's what goes with that. So that's how you can kind of figure that out. Our second example has an exponent, or an exponent raised to an exponent. So our rule, we'll write that over here. If I have an exponent and then another exponent on the outside of the parentheses, we kind of like distribute that and multiply. So we're going to apply that to our example here. So my rule here says I have an exponent on the outside here. So we're going to distribute that or multiply that by every exponent on the inside. So a to the third, and we're going to multiply 3 times 6, so a to the 3 times 6. And for our first one, -2 doesn't have an exponent, but if anything doesn't have an exponent, we could always add a number 1. Oops. Add a number 1 as our exponent. So 6 times 1 means I have -2. 6 times 1 is 6 to the 6th power. Now we can simplify this a little bit. Our exponents here, 3 times 6, a to the 3rd times 6th power, means we have a to the 18th power. So a to the 18th power. So we've taken care of this. My second one, I have -2 to the 6th power, and there's a reason why I put that in parentheses, because we have a negative number. So -2 to the 6th power, those are both numbers, so I can do that in my calculator. -2 to the 6th power. So -2 times -2 times -2 times -2, all the way 6 times. -2 times -2 is 4, times -2 is -8, times -2 is +16, times the -2 is -32, times the positive is 64. So our second rule here, we could simplify the -2 to the 6th power because they were both numbers. I couldn't simplify this a to the 18th any further because I had a variable and then a number as my exponent. So there's my final answer for number 2. And then number 3, we have our last rule if I'm dividing something with exponents. So if I'm dividing something with exponents, my shortcut rule we were using is to subtract those exponents. So if I'm looking here, I'm looking for those like bases again. I see that I have a to the 6th and a to the -3rd. These can go together because they're like bases. So we're going to subtract a to the 6th minus -3. means we get, well, a to the 6th minus a negative 3 gives us a to the 9th power. The second thing that can go together here are my plane numbers. So normal numbers are also like bases, but we just treat them like normal numbers. We don't use any exponent rules. So 4 divided by 2 here gives us a normal number of 2. So those are examples of our 3 exponent rules that we've been using last week. Each page of your packet will practice one of the rules. And at the top there are also extra examples if you need those. That's it.